Hey, Logicify! This video is going to be about resolution of vectors. In the previous video, we saw what vectors actually are, and we saw that vectors are any physical quantities with direction and magnitude. So this can be a vector. Let's say this is a force vector. Now, yeah, so force has a magnitude, and it has a direction. If you're watching this video, you would have come across many symbols like this. So let's say that this is the the y-axis, and then this is the x-axis. Now, you may have seen that there's a vector like this, and you may have seen something like this, that those are known as components. It looks like v. Let's say that if the vector is v over here, there might be something like this, which may be called v sine theta, and this called v cos theta. Now, what is this actually? How do we really understand this? This is a vector. This is something. Let's say this is a car. There's a car over here, which is going in a particular direction over here. And what does this actually mean, that it's going over here and over here? There are two vectors like that. What does that actually mean? Now, that is what resolution of vectors is. Let me give you an example. Let's say we have a plane flying. Now, and this is the ground, so it took off in this direction. Now the plane is flying with a velocity, let's say 230 kilometers per hour, and let's say that this angle it makes with the ground is 30 degrees. So if we are given a problem where we have to find the velocity of its shadow, if the sun is over here, alright, the sun is never blue, so it should be like this, and the shadow is never black, so it should be like this. Yeah, and let's say we have a problem where we have to find the velocity of its shadow. We actually calculate its component. So we say that there's a vector going in this direction and the component is in this direction. Now, component is actually the picture of this vector over here, v vector over here, in the x-axis and the y-axis. Components can be anything. They can be, let's say, if these are the axes, let's say this is a vector, right? And use the brown color. This is a vector. An axis can be over here. This can be a component, and even this can be a component when this is the real vector. So vector don't necessarily need to be on the y and the x-axis, but normally in physics we take it that way so that it's easier for us to calculate. And later I'll be posting a video where I show that during projectile motion, that is, let's say you throw a ball like this, alright, not over here, yeah, like where you throw it like this, we say that there's a vector over here, there's a vector over here, there's a vector over here. Now hopefully you will understand what I mean, and if you have any questions you can post it in the comments below. I'll just erase this. Now the question is, how do we actually resolve vectors? Now, let me take another example. Let's say we have a vector going like this, and let's say that it passes through the x-axis, or first the y-axis. Let me just use another color. Let's say we'll take maroon. Yeah, and this will be the y-axis. Alright, and the x-axis over here. Right, I went across somewhere. Alright, so yeah, this is the x-axis and this is the y-axis. Now we have a vector. Let's say this vector is called a vector, and let's say it's a distance. Now if you are given the angle over here, let's take the angle as theta, then the two vectors will be resolved in this direction if you're resolving it in the y-axis, y, and the x-axis. So it'll go like this. And this is the resolution of this vector into two components, and it's this component and one is this component. Now you saw that I wrote over here that this was a cos theta and this is a sine theta. Sorry, sine theta, and there's an n over there. Now how did I actually get this? Now these are free vectors. This is a vector and this is a vector. So I can with no problem bring this in over here. So if I bring this over here, it'll make something like this. Something like this. So what does this remind you of? Correct, it's a right triangle. So there's 90 degree over here, and when there's 90 degree we can actually use trigonometry. So we have theta over here, we have a vector a over here, and let's say these are the points O, P and Q. Let's not make it any congested over there, and let's start over here. So theta, so sine theta will be equal to AP, there's a perpendicular divided by hypotenuse, and that's a vector. Therefore AP will be a vector sine theta. Alright, we got one result. Now cos theta would be the base divided by the hypotenuse, and the hypotenuse is a vector. So OP divided by a vector, therefore OP is a vector cos theta. If you look carefully, this OP is this one and AP is this one. So we got our two results. Now this is known as the x component. That's because it runs along the x-axis, and this is known as the y component for the same reason that it runs along the y-axis. Now one question that may be bothering you for a while is that if you are given two vectors that is running along the y-axis and the x-axis, how do we actually find out the magnitude of this vector? That is the magnitude. These two bars show the magnitude of one vector. Now how do we do that? You may be knowing that when you have to find the magnitude along the x-axis, you move right or left the number of units that you're given. So let's say you have to move, you are given that this is 8I cap, that's moving over there, and then this is y, it moves over for, let's say, 6j upwards. So this component is said to be 6j and this component is said to be 8i. So this, the a cos theta and 8i is actually the same, and also 6j and a vector sine theta is the same. So to find the magnitude, all we have to do is find the magnitude together of the two components of the vectors. So we are given that a vector is equal to 8i over here and 6j over there plus 6j. Now to find the magnitude, all we need to do is find the root of the squares of the sum of both of them. The sum of the squares. So that will be 8 square, the 6 square, which equals, so I'll write the equal sign over there, which equals root 100, which is 10. So we can see that the magnitude of this vector will be 10, and it may be 10 meters per second, any vector, it may be 10 newtons, so any vector can run along this direction and it will be 10 newtons when the components are 8i and 6j. Now remember that the components can be in this direction and in this direction, so there can be a vector over here, but what we need to keep in mind then is that there will be negative component over here in the x-axis and also a negative component with the y-axis. So we need to keep that in mind. So if this is a graph given to you and you are given a vector which goes in this direction, the y component will be positive because it runs along the positive direction of y, but the x component will be negative because it runs along the x direction of the x direction. So this will be negative and this will be positive. Negative, positive. Now let's take an example. Alright, so we have an example here. Now the example says a boy pulls a sled along level ground by means of a rope under 78 newtons of tension. Now you need not know what tension is, but this is actually force. Newton is the unit of force. It's named in the honor of scientist Isaac Newton, on whose laws physics is actually based upon. So we have 78 newtons of force. Let me just use one good color. We have 78 newtons of force and it's moving along level ground. This is really important, and we will see that we actually use level ground to be the x-axis. The rope with which he pulls the sled makes an angle of 37 degrees with the horizontal. What is the magnitude of the component of the tension that actually moves the sled? Actually moves the sled and is wasted. So let's just draw one diagram first to just understand what this question actually is about. Now this is level ground and there's one sled. I'm going to draw it that well because this is a physics question and not an art class. So yeah, I'll just draw some gifts, some stuff. Yeah, and there's one person who pulls this and by the means of a rope. So he has a rope over here. Now to take it into physical terms, let's take the force over here. So he pulls it like this, and if this is the ground, let's take the ground to be the x-axis and the vertical to be the y-axis. So what they're asking is, what is the magnitude of the component of the tension that actually moves the sled? Now which is the actual force that moves the sled? This is a force which is applied by the person. This is the force applied by the person. This is a vector, force vector. Now the component of the force which actually moves the sled is along this direction. And which is the one which is wasted? It has to be this one. And why is it wasted? Because the man is trying to pull this over here. The boy pulls it over here, but this component is not actually needed because it's useless. Because isn't it a wastage if there's one thing going up when it's not even needed? So that's the component which is wasted. And what they are saying is that the x component over here makes an angle of 37 degrees with the ground. Sorry, the vector makes an angle of 37 degrees with the ground. So they're saying that this is 78 newtons too. So what is so let's solve for part A first. What they're asking is, what is the tension that actually moves the sled? What is the force that actually moves the sled? So force is the x component, and what is the x component of the vector? That will be F cos theta, and theta over here is 37 degrees. So it will be 78 times cos 37. I'm not going to calculate 37. Please go ahead and calculate it and get the final answer. So what is the force that actually moves that? That will be 78 cos 37 degree Newton. That will be the force that actually moves it. And what is the force that is wasted? Now the force that is wasted will obviously be going upwards because that is the component which is wasted. Now just choose the color. Yeah, so the force which is wasted is the sine component. So this is F sine theta, and this was F cos theta. Alright, so that's F sine theta, and that'll go along the y-axis. So this is the force that is wasted. So it will be 78 times sine 37. Yes, you guessed right. And that will be the component of the velocity of the the force that the boy applies, that will be wasted. Newtons. So you see, this 78 Newton was actually broken down into this and into this, and when you find the magnitude of these two together, you actually get this. Let's just do that just so you understand the concept right. So what will be the magnitude again? We said that 78 cos 37 is a vector plus 78 sine 37 is also a vector. Now how do you find the magnitude of vectors? Yes, you find the magnitude by taking the square of them and then adding it together, and then the under root of that, and the second root of that. So 78 square cos 37 square plus 78 square sine 37 square, which will be 78 square. We take this in parentheses, 78 square, sorry, that came out as a cube, and this will be sine square 37. And how much is cos square 37 plus sine square 37, or cos square theta plus sine square theta? That is equal to 1, and the root of that, so that will be 78 newtons. Voila, we got 78 newtons as f sine theta, that is this one, and f cos theta as this one. I hope you got the concept of this. I'll just add 2 more animations just so that it's perfectly crystal clear to you, so that you love physics. Thanks for watching.